Hello everyone, welcome back to my channel. My name is Piyush and this is the third video for 10 weeks of CloudOps. If you have not heard this name before, feel free to check out this video in which I have explained everything about the challenge. The task for challenge 3 was this, in which we were supposed to create a two-tier architecture in the cloud provider of your choice, either AWS or GCP or Azure, and it has to be done with the help of an infrastructure as a code tool such as Terraform. A huge shout out to 𝗧𝗨𝗧𝗢𝗧𝗧𝗧𝗧 and Ankit Jodani, who were the winner of this challenge. They have implemented the project exceptionally well, even the architectural diagrams and the blogs. So everything I'll put in the description section. And I will also be referring the diagram created by Ankit in this particular video for demonstration because it was too good to be ignored. And yeah, without any further ado, let's start the video. All right. So before writing the actual modules, we will be doing some prerequisite setup, like we'll be creating some folders and we'll be adding some files to it that is required for the Terraform configuration. So I'll open my VS Code and I have already installed Terraform. If you haven't, please like instructions are there in the description section. So you click over here to open a blank folder. So I'll go to my folder where I want to store all the code. So it will be over here. I'll create a new folder and I'll give it a name. Let's call it demo. Right. So the demo folder is now open, and inside that I will create two folders, one for your custom modules and one for your root module. Root module, like even if you don't create the folder for it, the default module that's been created for you is your root module, but I'll just try to keep it separate. So let's call it root. That's one folder. Create one more folder inside demo modules. Okay, now we'll start working with the root module itself. So click over here and create a new file, name it main.tf. Okay, this is where all your Terraform configuration will start executing from. So this is your main file. Consider this as a main function if you are programming in some language. So it will be called at the very beginning. You can keep all your configuration inside one big file, but that's not just a very good coding practice. So we'll try to keep it separate. Inside the same folder, we'll create one more file, which is variables.tf. So in this file, you keep all your variables, you define all your variables, such as, let's call it variable project name. Oh, by the way, I have installed the Terraform plugin from the marketplace. Like it's a Visual Studio Code plugin. So make sure you install that. So I'll start with this variable project name, right? And just open curly braces, and inside that there are some optional fields, but you can leave it like this as well, or you can just add few fields such as description, give it a value, would be your project name, and you can also give it a default value, right? But I just try to keep all the values separate in another file. I'll show you that. So that's the variable.tf file. Then we have one more file, which is terraform.tf_vars. So this name could be anything. It just has to end with .tf_vars or .auto.tf_vars. There are a couple of extensions that it supports. Significance of this file is the variables that you have declared inside your variables.tf. You can initialize your variable with a value over here, right? So let's say project name. This is the variable that we have defined. So let's call it 10 weeks of cloud ops demo, right? And your variable will be initialized with this value, as simple as that. Okay, now the next file that we will be creating inside the same folder, we are still working on root folder. So let's call it provider.tf. Right. Here you will add the details of your provider that you are using. Like we are using AWS provider, so we'll add the details over here, like its version number and its repository details. I have copied it. So I'm using this version of HashiCorp AWS provider. You can use the latest version as well. It just, I have tested everything with this version. So I'm pretty confident that it doesn't have any bug that could hinder this demo, right? And along with that, you could add a default region for the provider. You can use the syntax like provider, AWS, then region. You can give it region over here like US West 1, or what you can do is you can specify the same inside variables file over here. Let's give a name variable region. Okay. And the same way you give the value over here, terraform.tf bar files, region is equal to US West 1. And when you go inside your provider file, just enter, you can just access the variable using var dot region. So if you have installed the Terraform extension, it will show you something like this. Like it will show you all the autocomplete options and you can just select it very easily, right? So that's how you do it. Now, so we have till now discussed like the basic files, like variables, how to initialize that, how to use the providers. Now we'll be configuring something called a backend. So backend is required when you, so I'll create another file, backend.tf. Right? The content of backend.tf, I'll just copy it from. So by the way, everything that you want to use inside this is available in Terraform documentation. I will share you the link as well in the description. So feel free to use that documentation. Yeah. So this is the code of a backend. So backend is nothing but a storage location inside AWS from where you are accessing your TF state file. Right now, what exactly is TF state? Like all the information about your infrastructure resources will be stored inside this file when you run Terraform apply. So that like the next time when you run Terraform apply, it will just compare your desired state with the actual state. For example, let's say you have two EC2 server already created. You have to create one more. So you just add one more block inside your Terraform to create another server. So it will just compare that with the TF state file. Okay, so we already have two servers created and we just need to create one more instead of creating three servers. So that's the use of TF state file. But when we don't use the backend, it will just store the TF state file locally in your server and it will have some confidential data. It will have the details of your credentials. So it is a best practice to use the Terraform backend to store the TF state file so that whenever you run the Terraform command, it will be accessed from the S3 bucket and not locally. So for that, you have to create one S3 bucket, give it a unique name. I have already created that bucket from AWS console. And then you provide a path to it, like this could be anything. And then just the file name has to end with tf.state. You can give it names like prod.tfstate or test.tfstate so that you can keep all your environments tfstate files separately. And then you specify a region. The reason why we have not used variables in this file because the backend configuration does not support variables. So that's why we have hard coded it here. So that is fine. Then we have something called DynamoDB table. So let me show you how to create that. But before that, let's quickly understand why do we need it. So when you have Terraform configuration, you have stored your TF state file remotely in the S3 backend. Now there'll be multiple user accessing those configuration at the same time. It will acquire something called as lock to the configuration. To avoid that locking situation, you create a DynamoDB table, right? So again, this is one of the best practice. So what you can do is you can just log into your console and you go to DynamoDB. You go to tables. I already have created one, but if you want to create, it's pretty simple. You just create the table, give it a name, Dynamo demo, let's call it that, and make sure you use the partition key as lock ID. Only then it will be used in the remote backend. So just this thing you need to remember and keep everything as default and hit create table. So that's pretty much it about DynamoDB. Right, so let's go back. Okay, so we have configured our remote backend. Okay, now our main.tf is empty because we have not created any resources yet. So we'll do that in a bit. Okay, so we go inside the folder and we'll start creating modules. So if we look at the diagram, the first module that we will be creating is for VPC. Right? This will be our first module. And inside that VPC module, we'll be creating an internet gateway because it has to be attached to the VPC. Then we'll be creating two public subnets to host our NAT gateways, two public subnet to host our web servers, and two private subnet to host our database servers. So we'll be creating these resources inside the custom module VPC. Let's go ahead to our VS Code. So I'll create a new folder inside modules and let's call it VPC. Okay, and we'll basically use the same hierarchy structure. Like inside that, there'll be a main.tf, which will be the entry point to the VPC. And now, yep, so this is the VPC resource. Let me tell you what it is. So it is telling you that it is a resource of type AWS VPC. And this VPC over here, it's a reference name to this resource, which is internal to Terraform. This will not be your VPC name. This is how you will reference this resource internally within Terraform. Then these are the mandatory field. Again, if you look at the documentation, it will show you what are the mandatory fields and what are the optional fields. So the first one is CIDR block. Now you have to specify the CIDR block. We are using variables over here. So let's create one more file inside the VPC and call it variables.tf. Inside that, I'll copy all the variables that I have used in this and we'll see that one by one. But for now, just understand this is your VPC CIDR variable that we have used, right? This file over here. And then the default options for instance tenancy, and then keep it true for the DNS hostname support. And we have also used a tag with the help of a variable project name. Now, if you remember correctly, the project name, this variable we have declared and initialized in the root module. Now, how do the custom module access it? Right. So for that, let's go back to our main module. Okay. Inside that, we'll call the module. Let's use this syntax module and then name of the module, which is VPC. Inside that, there is a mandatory field which is called source. Like, what is the location of this module, right? So this is inside modules and then VPC. So this is our source location where the VPC module we have created. Now we'll be using project name as well inside that custom module. So, and project name is only defined over here, right? In the root module. Now we have to pass that variable to the child module. Okay, so we'll use that over here. We'll use the variable name, project name. Okay, and this would be var.project name. And this value will be getting it from here. And this is already defined over here. So when we use this, okay, I made a mistake. It has to be in the same line. Okay, so the curly braces should be in the same line where we are specifying the resource name. So now it will pass the value of project name from here, from the root module to the child module over here. That way we can use the variable from here using var.project name. Okay, then we have used another variable VPC CIDR. So again, the same way in the root module, we have defined the variable. So let me copy all the variables that is needed for this project. So I understood the process, right? How do we create variables in each of these files? And I will also be explaining as we are moving forward, right? So we have copied everything over here, all the variables. And now we'll be initializing these variables inside terraform.tf var files. All right. So this is the VPC CIDR range. And these two range are the public subnet for NAT gateway. These two ranges are public subnet for your web servers. And these two are the CIDR range of your database servers. Again, this could be a little overwhelming if you don't know how to calculate the IP addresses. For that, I have already created a video. It is just a 5-6 minutes of video. Please make sure you watch that before, and it will be really helpful. If you are aware of that, so that's okay. and like these database username, password, these are also some variables that we'll be using going forward, right? So this is done. Now if we go back to our VPC modules main.tf file, right? So this is how we'll be using VPC CIDR. We'll be using project name, okay? And inside variables, we have already added these four as well. Quick recap. So we have created all the prerequisite files. We have created our main.tf where we are calling our VPC module. We specify the source of it, and then we are passing variables from here. Okay. And the variable values will be taken from this file, terraform.tf var files, and it will be passed to the custom module. So I'll copy the rest of the variable side as well that we need for the VPC module. All right. So we are using source, region, project name, and then all the CIDR range that we specified in the terraform.tf var files. Okay. And if we go back, so this will create our VPC resource. So let's open a terminal window. Okay. I'll go to view and terminal, and I'll switch to bash. So I have opened my terminal window and I am in the same directory where my code is being stored. So I'll set the alias so that I don't have to type Terraform every time. After that, we need to download all the dependencies and initialize the modules, right? So for that, we use the command called tfinit or Terraform init. And it will say that no configuration file found because I'm not in the directory where our custom module or root module is present. I'm in the parent directory. So I'll go inside the root directory, clear the screen, and I'll run the command again. Okay, now it should initialize the backend. Now, if you see, it says successfully configured the backend S3, and Terraform will automatically use this backend unless it is changed, right? So our backend will be used for terraform.tf state file will be stored in the S3 bucket and it will be used remotely from there. And then it also installed the provider plugins for AWS, right? The version that we have specified, it downloaded that, and it had created some additional files inside this .terraform directory. So this directory would have modules, provider, TF state, right? It will have all those details, and this terraform.tf style won't have much details now because we have used the remote backend. And inside the provider, you will have the Terraform provider for AWS. Inside the modules, you will have module.json, and like these are some of the metadata. So, and it also created a log file. So that's good. Now that we have initialized the backend, the next command that we can run is tfplan. It will show you how many resources will be created or deleted or modified when you run Terraform apply. So this is just a dry run of Terraform apply. Right, so we have initialized the backend. We cannot run Terraform plan at the moment because we have some additional variables that's been added in like most of the files. So we will be doing it at the end, right? But we have created the module and we have added the VPC resource to it. But after that, we will be adding internet gateway and all the subnets that we talked about. So this is the code of internet gateway, and it will create the internet gateway and attach to the VPC. It's of type AWS internet gateway. By the way, there is one quick hack if you want to go to the documentation of any of the resource. So just hover the mouse to it and just hit control button, and it will redirect you to the Terraform's official documentation like this, right? So you can see all the details like your resource type is AWS Internet Gateway, and this is your internal name. Then all the arguments like the optional values and the mandatory values, the reference to it, it will have everything that you could do, right? And on the left side, because this is AWS provider, you see all the resources, right? And you can search it here in the filter box as well. Just wanted to share this with you. So I'll go back. Okay. So internet gateway, and then we have specified VPC ID over here because we need to attach internet gateway to the VPC that we have created. right? So this is how you will do that: aws-vpc.vpc.id. So it will take the reference of, okay, let me show you. Let me delete this. So aws vpc was the resource name, and then when you type it, it will auto populate that with this resource type we have only one resource created or available in this module, which is vpc. So I'll enter dot vpc, and then if you enter one more dot, it will show you the attributes that is available for the vpc, right? So these many, and what we need is the id, vpc id. So here it is. I'll select that, and this is what we need to associate it with the vpc. If you see over here, aws vpc resource name dot vpc, because as I've told you before, we are referring the resource with its internal name. So this is what it is, and then dot id. The same way we have specified tag, it's nothing new. Okay. Now we need the details of availability zones. We don't want to hard code it. So we need some function or some service that would fetch the availability zones from the region that we have specified. So for that, we will use something called as data source. Right? Data source, you specify this with the name data and then name of the data source, and then this is the internal name. Now, when you want to use the available data sources, what it will do, it will reference this part over here, and it will get the values from your AWS region. I'll just copy the rest of the configuration for this module. I paste it over here. This is data source, and then here we are using it availability zones equal to data dot AWS availability zone, which is this one, and then dot available zones, which is another attribute, and then names. So because you see over here, it is 0 inside the square brackets, that means it is an array. So 0 is the index of that array. So we'll be getting the first element of the array with a 0 index. This is for public subnet 1. And if you go down public subnet 2, we will be fetching the next element of the array with index 1, and the same way for other subnets as well. Now we will also be creating a public route table. So all of these resources like VPC, route tables, internet gateway, I have explained this in detail in another video, which is like the link in the description. So make sure you watch that if you want to know about it. If you are familiar with the concept, then this particular video is just to demonstrate the Terraform, right? So we are creating a route table with a public route, right? Attach like with the VPC ID, and then route is internet gateway will be the destination, and just a tag, and then we attach that route table to the subnet, right, using subnet ID and route table ID. The same way we are doing it, like we are getting subnet ID from AWS subnet resource that we have created in this module itself, and then using this was the first subnet, and then dot id. For the second subnet, this was the association. So now we have created two subnets and two route tables, and then associated that route table with the subnets, right? So these are the two other subnets, and then we have created two private subnet for databases, and then basically that's it for the VPC module. I'll just save the file. So that would complete our first module, which is VPC. The same way, I'll add the configuration of the next module. If we go back over here, now we will be creating NAT gateway module, which is over here. So two NAT gateways, so that the instances in the private subnets, these instances will have access to the internet through NAT gateway. So this is how it will access the internet, and it will be over a secured line. So that is why we need it. Okay. So if we go back, so here are the details of NAT gateway. We are doing basically the same thing. We have an internet gateway ID, which we got it from the module VPC. So when the VPC module got created, we can reference all the output from that module as an input to this, right? So consider this. It could be a little confusing, but if when you try it, when you do the hands-on, you will understand. But let me try to explain. So you have a root module, And then you have two child modules. Let's call it child 1 and child 2. Okay. So when you are creating any variables over here, right, you are passing it through the module to the child modules, right? Like this. So whatever values you have specified over here, it will be present in the child module because you are passing it. But like whenever you create a child module, how would you access the values from that child module into the other child module? So what you do for that, let's say this child 1, it was VPC and the child 2 is NAT. We need internet gateway ID from here and it should be used in the NAT gateway. So what you will do is you do like this. You do module.vpc.internet gateway ID. So that means value is getting fetched from here through a new file called output variables. Okay. And then it will be fetched to the root module, and then root module will pass it to the other child module, right? So these two child modules does not have any direct relationship with them. They will be accessing the resources through the parent module, right? So consider this like these are two brothers who doesn't get along well. So whatever they want to communicate with each other, they do it through their parents, right? So the same way, what we are doing is, so we have to first create another file inside the VPC module and call it output.tf. So I'll add all the variables over here. So let's say we need to use internet gateway ID, right? So you specify like this: output internet gateway ID, like IGWID, and its value would be generated from this resource, which was part of. I added in the wrong file? I added this file at the wrong place. So let me just drag it inside this VPC module. Yeah. So this resource was created inside the same module, VPC module, and dot internet gateway would be the ID of it. Now we will be taking the output from this module. Okay. And then we are capturing that output inside the main.tf of root module like this: module.vpc.internet gateway ID. This is your output variable. And then we are passing it to the NAT gateway module through this, right? Because we are passing it from this to this internet gateway ID. It will be like VPC module, output variable, then it would be root module, it would be captured in root module, and then root module will pass it to your NAT gateway module. This is how we'll be transferring the values from one module to another module. Try to understand this concept. When you do the hands-on, you will get to know a little more than that. It could be a little confusing at the beginning, but when you try doing it by yourself, it will be really handy, and you will understand it thoroughly. Okay, so that's for that. Now our VPC module will have three files: main, output, and variables, right? And the same way we have created. Okay, and inside main.tf, now we were here for the NAT module. Now we'll create one more folder inside the modules directory, call it NAT. Okay, inside NAT, we'll create all those files like main.tf, variable.tf, and output.tf. I'll add those values, and now I'll fast forward this video to the point where I have added all the modules and all the features, and then we'll go forward from there. Okay, so after I have made the changes, I rename the folder as well, and this would look something like this. So we have the modules created for your load balancer. Let's quickly see what it is. That load balancer, we will be having an application load balancer resource, which will be listening the traffic on port 80, and it will have some health checks so that it will add or remove the instances based on the availability of instance. and then it will have a listener that will redirect the traffic on port 80, and it will just forward the traffic to that target group. And then we have application security group, right? So again, these all things we have discussed thoroughly in the previous video, so make sure you watch that if you want to know what these resources are. So we created a launch template. Inside that, we have used all the variables and everything, and then we have used a user data script. So if you have worked with AWS before, within EC2 section, there is an option of user data script where you could add some scripts, some arbitrary commands that you want to run once your EC2 is booting up. So in that, so I have put all the content in a separate file over here. So it will basically have your application code. So that application code is just a sample application, and it will be running on an Apache server, and it will just install the package dependencies and restart the service. That's what it is. And then it will clean up some temporary files, right? So our application will be deployed with that script. Then we have CloudFront because we will be using some static images. So that's why we have used a CloudFront distribution over here. And it will use the AWS certificate as well from the ACM. So make sure you have a valid and issued certificate within ACM for your domain. This ACM certification part we have covered in video number 1, so we are not going to that again, but you can have a look at that. And yeah, and then we just created the CloudFront distribution, and we specified the location as these, like India, US, and Canada, or we could use the global location as well. It's up to you. Yeah, and then we have a public and private key pair created because we will be needing some keys. Like if we are using EC2 Instance Connect, then yes, we don't need to generate the keys. But if we are using any external client such as Putty, then yes, we need a public and private key pair. So this is what we have used. Then NAT gateway we have already seen. We have created an RDS instance of MySQL in which the data will be stored. So we have created an A record which will point our application to the CloudFront distribution in which it is hosted. Then this is the security group module, VPC I have already seen, and then we have the root module. Now, make sure you add all the files that you don't want to commit in the GitHub in this git ignore file, files such as tf state file. We have already used the remote backend, so that step is not necessary, but there are some backups generated. Sometimes there is a log file generated, so make sure you add that. And then some files such as tfvar files, because this is specific to a user, so we don't want to commit it. It could have some confidential data as well, like we have used db username password, although this is not the secured way of doing it, but even then, so make sure you don't commit that in your git repository and put that inside your git ignore file. And then this directory .terraform, like I have shown you, it will have some metadata. It will have the providers executables that you don't want to commit, so you can put these files in your git ignore file. Yeah. And so when you are following it, you know, you can follow this GitHub repository that I have created. I have uploaded everything in this repository, and it has steps as well, like the prerequisite: create an S3 bucket, create a DynamoDB table. It has the steps: create a public private key pair, then then ACM certificate should be present with the status as issued. A Route 53 hosted zone, this also you need to create, and then you need to update the values in this file as per your requirements, and then you can just run the Terraform command. Now if we go back, we will run Terraform plan again to see the resources that will be created. Okay, let me set the alias f and then tf plan. Okay, I'm not in the right directory as always. I'll go to the root directory and then I'll run tf plan. Okay, now it will show you that 38 to add. If there were any modification, then it will show you over here that 0 to change now, because we are just creating it from scratch. Else it would have shown you only the modified resources. and 0 to destroy if you are running with an empty file, or if you have removed any resources from the file, that means it has to be destroyed, so it will destroy those resources. So yeah, 38 plan to add. If you want to know like what all resources it will create, so you can scroll up and you will see all the details over here. Then you can also grab this keyword, will be created. So these are the 38 resources that will be created. So these are 6 subnets, 1 VPC, okay, and route tables. Then we have there was CloudWatch metrics as part of auto scaling groups. So auto scaling groups, target load balancer, load template, CloudFront distribution, public private key pair, elastic IP, net gateway. It has everything. When you have to execute this, so you run Terraform. Okay, let me clear the screen first, and then you run Terraform, apply, hyphen auto approve if you don't want it to prompt you for yes or no. Then this will just start provisioning your resource. Okay, so it started creating the resources. It says creating, and it will create the resources in parallel. It will take some time because there are a lot of resources. And so yeah, so let's pause the video and then I'll come back once it is done. All right, so after around 15 minutes, all the resources are created. It says 38 added. So AWS database instance took most of the time because it's a managed service. It's a managed RDS service and it takes its own time. So that's okay. Now let's have a look and see if we are able to access our application or not. So I'll go back to my AWS console. I'll go and find the DNS of load balancer. It will be part of EC2. And then if you scroll down, you see load balancers over here. And there'll be one load balancer that was just provisioned with this infrastructure. Now you can copy the DNS name of that and you should be able to access it. All right, our application is up and running. This is, I'm not sure what was that. I think it's a matrimony site. So now you go to your CloudFront and what's been created with this provisioning, grab the domain name and your website should be accessible over this domain. Let's see. Yeah, our application is up and running, and you can also see like SSL is enabled. Now you can easily create a record in Route 53 and point this to your custom domain. So that should be it. And once you're done, once you've verified everything, don't forget to destroy your resources, else it will accumulate a lot of cost for you. So you go back to your VS Code and run the command df destroy and auto approve, and it should destroy all the resources that was created by the Terraform. And yeah, basically that's it for this video, guys. Thank you so much for watching. I hope it was helpful to you. Again, the links of the projects created by Ankit and Mahesh are in the description section, along with the GitHub repository that I have used in this demo. So feel free to fork the repository, feel free to clone it and try to implement the project on your own. Let me know in the comment if you need any help or assistance, or join our CloudOps community Discord server where there are a lot of amazing folks who are ready to help you out. We grow together as a community. So yeah, all the links are in the description section. Feel free to have a look, and thank you so much for watching, and I will see you soon with the next video.